In this lesson, we're going to go over the substitution rule with indefinite integrals. So the substitution rule says, let f and g be functions such that f of g and g prime are continuous on an interval I. If capital F is an antiderivative of f on the interval I, then we have that the integral of f of g of x times g prime of x dx is equal to capital F of g of x plus c. And I just want to note that the substitution rule is often referred to as U substitution. This example says evaluate the indefinite integral. So for part A, we have the integral of cosine of 4x dx. So you'll notice you have a composition of functions. Your outside function is cosine, your inside function is 4x. So since we have a composition of functions, we're going to use the substitution rule, or U substitution, in order to integrate. Over here I have a chart, and the way we're going to use it is first we're going to identify U. U is going to be the inside function. So we're going to write U equals 4x. And what we're going to do in here is we're going to take the derivative implicitly with respect to x. So since this is an x, we take the derivative and we just get 1, but then we times that by du dx. Over here, the derivative of 4x is just 4. And again, we just write 4 because we're taking the derivative of this with respect to x. And next, because we have a fraction equals a number, this is a proportion, so what we can do is we can cross multiply. Remember, when you cross multiply, you're multiplying across, so you would say dx times 4, and then technically there's a 1 down here, so you'd say 1 times du. But what we're trying to do is we're trying to get dx by itself. So if we bring this dx up, you would have 4 times dx, but then you could divide the 4 out. So what happens is you get dx equals du divided by 4. So again, the dx comes up, and then you're dividing both sides by 4, so you get du divided by 4. And now dx has been isolated. So now we're going to go to our problem, and we're going to rewrite cosine of, and we're going to plug in u for 4x. Next, we have dx, and over here we've shown that dx is equal to du divided by 4. And what we've done is we've taken the original problem and we converted everything to be with respect to u. Next, this 4 is technically a 1/4, so I want to bring that to the front of the integral. So now we just have the integral of cosine of u du, and we're ready to integrate this. The integral of cosine is sine, and then we're going to put plus c. For our very last step, I'm going to put a little arrow over here just to remind ourselves, kind of to refresh the problem. We're going to take this u and plug it back in. So for our final answer, we get 1/4 sine of 4x plus c. For this problem, we have the integral of 2x square root of x squared plus 1 dx. So what we want to do first is, you can see you have a square root right here. The function inside of the square root is x squared plus 1. So kind of similar to the last problem, our outside function is the square root of x. The inside function is x squared plus 1. So we're going to let u equal x squared plus 1. So again, when you're setting these problems up, you're going to let u equal the inside function. And you're probably noticing that you have this 2x over here. We're going to leave that there and we're not going to touch it. That's going to be what I call the rigged part of the problem. And you'll see why in just a second. So at this point, we're going to work over here. We're going to take the derivative of this implicitly with respect to x. Again, the derivative of u with respect to x is 1, and then we times by du dx. On the side, when we take the derivative with respect to x, we just get 2x. And just like the last problem, we have a fraction equals one term. So we can cross multiply. So I'm going to do this in one step. We're going to bring this dx up. And at the same time, we're going to divide both sides by 2x. So you get dx equals du divided by 2x. So now we're going to take these and we're going to plug them in. First, we're dropping down this 2x. And then we go square root of u, and instead of dx, we're going to write du over 2x. So remember when I said this was the rigged part of the problem, this works out great because you have 2x here and you have 2x here. So now you can simplify, these are going to cross out, and then all you have left is the integral, and I'm going to rewrite this square root of u as u to the 1/2. So now we're ready to integrate. Remember, when you integrate, you're adding 1 to the exponent, so you get u to the 3/2. And we divide by the new power, which is the same as multiplying by its reciprocal. So we're going to times by 2/3. And then we're going to put plus c. And finally, our last step is we're going to refresh the problem. We're going to plug our u back in. So our final answer is 2/3 times the quantity x squared plus 1 to the 3/2 plus c. For part C, we have the integral of sine of the square root of x divided by the square root of x dx. So what we want to identify is right here we have a composition of functions. Our outside function is sine, our inside function is the square root of x. So we're going to let u equal the inside function. So u equals the square root of x, or I'm going to write this as x to the 1/2. So I wanted to note that this square root of x down here is going to be the rigged part of the problem. So we're going to use this later. All right, so next we're going to take the derivative of this with respect to x. So the derivative of u with respect to x is going to be 1, and then we times by du dx. The derivative of x to the 1/2 is going to be 1/2 x to the negative 1/2. And we're going to rewrite this as 1 over 2. And then because this has a negative exponent, we're going to move it to the denominator. So it's going to be x to the 1/2 down here, but then I'm going to rewrite it as square root of x. So here we have a proportion, so we can cross multiply. And if you'll notice, this dx, we multiply it up, and we're going to take this 2 root x and multiply it up as well. So when we cross multiply, we take the dx and times by 1, and we take the 2 root x and times by du. So we get that dx equals 2 root x du. Okay, now we're going to go back to the problem and plug this in. So we're going to go sine of, and then we're going to put a u here. It's really important to note that this is the rigged part of the problem, so we're going to leave it. So we're not going to plug u in for it. Again, where we have a composition, that's where we put u, but we're going to leave this right here, and you'll see why in just a second. In place of dx, we're going to substitute 2 root x du. And so you can see now the square root of x's are going to cancel, so that worked out really conveniently. And then we're going to pull this 2 to the front. And now that we have this all with respect to u, we can take the integral. The integral of positive sine of u is going to be negative cosine of u. And again, the derivative of cosine of u is going to be negative sine of u, and the negative negative become positive. So finally, we're going to refresh our problem and plug u back in. So I move the negative to the front, so you get negative 2 cosine, and then we plug the u back in. So our final answer is negative 2 cosine of the square root of x plus c. Here we have the square root of x e to the negative x squared dx. So we're looking at this, and our composition occurs right here. You have e to the negative x squared. So the inside function is negative x squared, and the outside function is e to the x. So we're going to let u equal the inside function. So u equals negative x squared. So over here we have the rigged part of the problem, so we'll use that later. Next, we're going to take the derivative of this with respect to x. So we get du dx equals negative 2x. Next step, we're going to cross multiply, so we bring the dx up, and this negative 2x is going to come down. So we get that dx is equal to du over negative 2x. Okay, and we're ready to plug everything in over here. So we just leave this x here because that's the rigged part of the problem. And then we go e to the u, and dx equals du over negative 2x. And again, the rigged part of the problem helps us because when we took a derivative over here, it generated an x, and that x is going to cancel with this rigged part of the problem. And then this negative 2, I moved it to the front as a negative 1/2, and so we have the integral of e to the u du. So we're ready to integrate. The integral of e to the u is going to be e to the u, and then we add c. Last step is to refresh the problem and plug our u back in. So we get negative 1/2 e to the negative x squared plus c. For this example, we have the integral of x cubed over x to the 4th minus 5. What we're going to do is we're going to consider this the rigged part of the problem. So we're just going to leave that there. That means we have, for the rest of the function, we have 1 over, and then this is the inside function. So the inside function is going to be x to the 4th minus 5. The outside function is going to be 1 over x. So we let u equal the entire denominator, so u equals x to the 4th minus 5. The derivative of x to the 4th minus 5 is going to be 4x cubed. We have a proportion, so we're going to rewrite this. We're going to bring the dx up, and we're going to move this 4x cubed down. All right, we're ready to substitute this in. Again, leave the x cubed because that's the rigged part of the problem, so we're just going to leave it there for a second. We're going to substitute in u for the x to the 4th minus 5. And we plug in du over 4x cubed in for dx. Remember, this was the rigged part of the problem, and it works out great because that x cubed is going to cancel with this x cubed. And then this 4, I'm going to pull that to the front as a 1/4. And now we're ready to integrate. The integral of 1 over u du is going to be ln absolute value of u. So now we're ready to plug u back in. So we get 1/4 ln absolute value of x to the 4th minus 5 plus c for our final answer. This example says the integral of sine squared of theta cosine theta d theta. For our first step, I want to take this sine squared of theta and rewrite it as sine of theta quantity squared. By rewriting it like this, you can see the composition of functions a little bit easier. We're going to let u equal the inside function, so we're going to let u equal sine of theta. Next, we're going to take the derivative of this with respect to theta. So the derivative of u is 1, and then we times that by du d theta. The derivative of sine of theta with respect to theta is going to be cosine of theta. We have a proportion, so we can cross multiply. We can bring the d theta up. We can move the cosine of theta down. And now we're ready to plug everything in. So we plugged u in for sine theta right here, so you have u squared. This is the rigged part of the problem, so you just leave it there. And then d theta equals du divided by cosine of theta, so we put that here. And again, it worked out great because the rigged part of the problem is the same as what was generated when we took the derivative. So we can cancel these out. So now we have the integral of u squared du, and we're ready to integrate. So when we integrate, we get 1/3 u cubed plus c. And finally, we're ready to plug u back in. So we plug sine of theta back in for u, and I just rewrote this as sine cubed of theta, so we have 1/3 sine cubed of theta plus c for our final answer. For this example, we have the integral of x to the 5th, square root of 1 plus x squared dx. So right here you have a composition of functions. Your outside function is the square root of x, and the inside function is 1 plus x squared. So we're going to start off this problem by letting u equal the inside function. So we have u equals 1 plus x squared. We're going to take the derivative with respect to x. And here we have our proportions. We're going to cross multiply and bring the dx up and move the 2x down. Okay, so we're going to plug this in. Since u equals 1 plus x squared, we're going to plug it in right here, but instead of writing the square root of u, we write u to the 1/2. And then finally, dx is equal to du over 2x. At this point, you're probably noticing this is a little different than the previous problems. Right here, we have a 2x, which was generated by taking the derivative. But up here, we have x to the 5th. So we're going to cancel this x with one of these x's. So that leaves us with x to the 4th. At this point, I'm going to pull this 2 to the front. And at this point, we still have an x to the 4th that we're going to work with. So we're going to rewrite this expression down here. And what I want to do is isolate the x squared. So if we subtract 1 from both sides, we get x squared equals u minus 1. So since we have x squared equals u minus 1, we're going to take this x to the 4th and we're rewriting it as x squared quantity squared. So now we can plug in u minus 1 in for x squared. So at this point we have u minus 1 quantity squared times u to the 1/2, and before we can integrate, we need to manipulate this. So first we're going to multiply this out. So u minus 1 quantity squared, when you FOIL it, you get u squared minus 2u plus 1. So I substituted that in here. And then next step, we're going to take this u to the 1/2 and we're going to distribute to all three terms. And don't forget, when you're multiplying with the same base, you're going to add the exponents. So we're going to get 2 plus 1/2 or 2.5, and that's the same as 5/2. Right here, when we multiply u times u to the 1/2, this is u to the 1 times u to the 1/2, so you add exponents, you get u to the 1.5 or u to the 3/2. And now we're ready to integrate. So we're going to add 1 to the exponent, which is 2 over 2, so we get 7/2, and then we multiply by its reciprocal, 2/7. Right here, we're going to add 1, which is the same as adding 2 over 2, so we get u to the 5/2, and then we're going to multiply -2 by the reciprocal. So we're going to go -2 times 2 over 5, and we get -4/5. Okay, at this point, I'm going to take this 1/2 and distribute it to all of these terms. So when we multiply 1/2 by 2/7, the 2's cancel, and we're just left with 1/7. When we multiply 1/2 by -4/5, the 2 and the 4 reduce, and it leaves a -2/5. And then 1/2 times 2/3, the 2's cancel, and we're left with 1/3. And our very last step is we're going to plug u back in. So I'm going to put a little refresh arrow here to remind us. So we're going to plug this u back in. So 1 plus x squared gets plugged in for all of the u's. So here's our final answer. All right, guys, thanks so much for watching.